the midterm. Okay, your room is going to be building G. I sent you the room, I think 2008. Okay, and so you have to be there before time. And remember, this is an open exam. You'll have 10 problems, with each problem 2 questions. 2 questions are almost independent from each other, so you can, if you do not solve one, you can solve the next one. Okay, so each question is about 5 points, and in order to get partial credit, you have to show equations and show your steps. So it's not enough to just show the final answer. Please make sure you show all your steps in order to get partial credit. Okay, I will be available most of the time. If you want to call me with Microsoft Teams, you can call me. Tomorrow morning and Thursday morning, I will be in 2011A. In the afternoon, I'm in my office, but you can reach me with Microsoft Teams in the main campus. I wanted to arrange a review session to go over all the exam that I posted, but it seems you have exams at night. So I will leave it up to you. I will post the solution for the exam I put in Blackboard. This is from KFUPM. It's an old exam. Okay, so I will post the solution, and if any of you has a question about these problems or other problems, or something is not clear, make sure you contact me, you come see me, and so on. So this is the time I really want you to make sure that you understand everything. The exam is I think 30% of the grade, so this is a very important exam. Okay, so let us solve a few more problems from chapter 26 so that we complete what we started. So let me start the Kahoot for chapter 26. So please, your pen and pencils, and you can work in teams. Everybody log in Kahoot, but you can work in teams. Okay, so 940-9820, 940-9820. So log in, please. Hello, Shabab. Okay, so let me post the question while everybody is joining. Okay. Okay, so let's have 2 minutes for question A. 2 minutes. Okay. Start the timer. Okay, ready? Huh? Anybody's ready? If you finish, raise your hand. If you finished, raise your hand. Okay, a few more seconds. Okay. Part A, question A. Eh? Okay, so choose between A, B, C, or D. Okay, so I'll start the Kahoot. Ten seconds only. Eh? Okay, good. 15 correct answers, and we have 9 incorrect answers. Okay, so let's look at this question. Okay, so a heating element is made by maintaining a potential difference of 75 volts. Okay, so this is 75 volts of a nichrome wire, and it has a resistivity of 2.6 10 minus 6. Sorry, it has a cross section. This is a cross section area. Okay, the nichrome has a resistivity of 5 10 minus 7 ohm meter. Okay, question A, if the element dissipates 500 watts, that's power, what is its length? Okay, so we have many equations for power. We have power is delta V times I. We have Ri squared, and we have delta V squared over R. Okay, so here, since we are given the voltage, so I will use this one, but I need the resistance. We know the resistance R is the resistivity times the length divided by the area, which is pi R squared. Okay, so we can write that this is equal delta V squared. So delta V squared divided by rho L over A, so A will go up here. Okay, so now we can solve for L. So this means we can write L is equal A delta V squared, where is pi R squared. So pi R squared times delta V squared divided by rho times the power. And when you do that, you find that the length is 5.85 meters. 5.85 meters. So this is question A. Okay. Question B, if 100 volt is used to obtain the same dissipation rate, so now we changed the voltage, okay, and we have the same power. What should the length be? So I can use the same equation. So L, and you will find that in this case it's 10.4 meters. Okay, so we used the equation for power, and we used the equation for resistance. Clear? Simple problem. Next question. Okay, 2 minutes for this one. 2 minutes. You can read it, or should I read it? Okay, at what temperature would a resistance of a copper conductor be double its resistance at 20 degrees centigrade? Use 20 degrees centigrade as a reference point and compare your, well, we don't need to compare. So you're given alpha is 4.3 10 minus 3, which is the coefficient of temperature for resistivity. So solve it. Make sure you know how to do this one. Ready? Huh? Raise your hand if you're ready. Okay, most of you are ready. So choose between A, B, C, or D. Five seconds remaining. Okay. Wow. Everybody has seen the answer, I guess. Yeah, huh? Not much of a game when you have the answer already. Huh? But still, two managed to get the wrong answer. Okay, so let's. And the important thing is knowing how to solve. Huh? So remember, we're practicing for the exam. Okay. So at what temperature would the resistance of a copper wire be double its resistance at 20 degrees centigrade? So 20 degrees centigrade is T0. T0, sorry. T0. Okay. So what do we have? We have an equation for resistivity and resistance. And the equation says R is equal R0 times 1 plus alpha T minus T0. It's the same equation for resistivity. So since resistance and resistivity are proportional. Okay. So this temperature here, we want to determine the temperature at which this resistance is double the resistance at 20 degrees, which is 2R0. So this is equal to 2R0. Okay, so that means 1 plus alpha T minus T0, and T0 is 20 degrees centigrade, is equal to, because the R zeros will cancel. So alpha T minus T0 is equal 3. 2 minus 1, so 1. And so we have T minus T0 is equal 1 over alpha, and T is going to be equal 1 over alpha plus T0. And when you do that, you find this is equal to 253 degrees centigrade. 253 degrees centigrade. So be careful. Are the answers in Kelvin or centigrade? So if you have the answers in Kelvin, then you have to convert to Kelvin, and vice versa. So make sure you know what are the units that are asked for. Next problem. All right. So here I want you to solve question A. Question A. Okay, and I'll give you also 2 minutes and a half. 2 minutes and a half. In this case, you don't have the answer. Okay, so I have given you for copper, the molar mass is 63.5 grams per mole. The density is 8.92 grams per centimeter cubed. And assume 1 free electron per atom. 1 free electron charge carrier per atom. Ready? Okay, ready? Raise your hand if you're ready. Okay, we have almost half, and for the sake of time, we want to move. Okay, so let's start the Kahoot. Okay, so let me make sure. Why it's recording.